Hello everyone, welcome to the NLP final project of Team Avalon. My name is Annie and I will give an overview of our term project on the question generation and answering system of Wikipedia articles. So these are the tools that we have used: Python 3, NLTK, and Spacy. And next, let's take a look at our system architecture. So on the left-hand side is our question generating system. We're taking a Wikipedia article and an integer n, which is the number of questions we want to generate. We first apply sentence segmentation, word tokenization, and POS tagging on the article, and then feed in the sentences to binary question generation and WH question generation. For WH questions, we also have the NER tagging, which help us determine the type of WH question we want to generate. Then we feed in all the questions to our question ranking system and output only the top n good questions. For the right-hand side is our question answering system, which takes in a Wikipedia article as well as a list of questions. We start with sentence segmentation on the article and retrieve the best match sentence within the article compared to the question. Then we determine the type of questions, either binary or WH questions. And for binary questions, we check if the meaning of all part of speech matches. And for WH questions, we determine if the NER tag that corresponding to the question words and output the answer. If there's no answer found, we then go back and find the second best match sentence from the corpus and do the same logic again. So then I will go into more details of each part and some techniques that we use to improve the performance of our system. For the binary question generation part, we first identify the head verb of the sentence and extract the tense and move it to the beginning of the sentence. For example, in this case, we move the past tense to the beginning of the sentence. And to improve the complexity of the question, we also replace the adjectives in the sentence with its synonyms or antonyms. So for example, we can replace early with late. We also remove the conjunction words and negative words such as never or not to improve the fluency of the question. So for example, in this case, we remove all the parts after and only generate questions based on the first half. For WH question generation, we only generate questions for a sentence with NER tagged entities and give up sentences with negation words to make sure that we only generate meaningful and fluent questions. We also pick the question word according to the labeling of NER tagged entities. For example, if the tag is number, then we generate question word to be how much. We also truncate our sentences according to the dependency tag. So for example, in this example, the first diamond was found in South Africa. In the question, we remove the preposition in. And at the last, we rank our WH questions based on their difficulty to answer. Why, which, what, how, where, and who is the order of our difficulty. Then after we generate a list of all binary and WH questions, we feed them into a ranking system, which contains our hand-labeled features, which we find to be more error-prone. That includes the length of the sentence being too long or too short, containing unmatched parentheses, having too much punctuation marks, or having third-person pronouns. Then we assign weight to these error-prone features and rank the questions by the total score and output the top n questions with the lowest error-prone score. Then let's move on to the answer generation part. For the WH question answering, the where, who, and when questions, we first check their corresponding NER labels and return the respective text. For how questions, we know that they often deal with quantity or measure, so we return the corresponding text with the NER labels including quantity, percent, money, or cardinal. For why questions, we first find if the sentence include any because or its synonyms words. Then truncate the sentence on the because word and compute the similarity scores of each part with the question sentence. Then the part with the less similarity score will be more likely to be the reasoning of the question. For what type of questions, we first find the POS tags on the question to identify the adjacent word to the what tag. It's always adjacent to being words such as is, are, was, or were. Then we return the matched adjacent tags and the corresponding tags with the NER labels. The which question is very similar to what. Then let's talk about our binary question generation. We first apply the NLTK POS tags on both question and the sentence. Then for each question, for each tag on the question and the sentence, we check if the corresponding POS meanings match. We will catch any synonyms or antonyms and negation words. And we will also have a Boolean value, which allows us to keep track of the number of negations. So an even number of negations actually results in a positive result. In the last part, we will talk about our evaluation system. So for the question generation, we apply manual testing on the fluency and reasonableness of the question. We will assign points as the rules listed out here. And for the question answering part, we had a semi-automatic evaluation system, which we will first manually generate answers to a list of questions, and then having the system to calculate the hard match and soft match accuracy on the system-generated answers and the manually generated answers. The hard match is the exact string equal, and the soft match is a partially match. So based on our question generation and answering evaluation, we did some improvement to our system. For the generation part, we removed the co-reference resolution using neural co-ref because actually we saw the performance decreased after adding this feature. We also find that the question quality ranking and assigning the org tag from what to which organization actually improves the performance. So we keep these two features. And for the answering part, we identified that actually using POS tagging, such as non-verb adjective match, actually performs better than using the dependency parsing, which gives us subject and object match. So we decided to move forward with the latter approach. So with that wraps up our final report. Thank you very much for listening.